conditions of loops. Now we are going with the path sensitives and path instructions. So it's visible to you guys? Hello? Visible?
Yes, ma'am, it is.
Okay. So path sensitive is nothing but we have the path sensitive, achievable path, unachievable path, and the path sensitive. So in this, what we are doing means you are finding the path sensitive path. Okay, we are finding the in previous class we are going with the paths, right, in the graphical control graph. So by seeing that you are taking the one path to the another path. So like that we are finding over here. Okay. So next in this path prediction, what you are doing means we want to select and test the enough path to achieve the nodes to test the completeness of your path. So you are checking the path. Okay, you are selecting the path. Okay, complete path from starting node to the ending node. You are selecting the path from starting node to ending, and we are finding that prediction. We are doing the prediction on that path. Okay, so then we are multiplying with this. Okay, like such C1 plus C2 like this. So we are doing the path sensitivities. So in this, what you are doing is the program control for graph are in select a set of coverage path. So in here, what they will do is they will coverage the path of from one node to the another node. Okay, from one path to the another. For example, you have the some path like from. So this is your path 1, 2, 3, 4, 5, 4, 6, 7, 8, 9. So from starting to the end, so they are selecting the control flow graph of your path in the path sensitivities. Okay, tagging the path through the multiply the individual component, predicting to achieve a Boolean expression. Okay, so you have one. So this is your Boolean expression, guys, of path sensitive. So what we are doing is we are just now I said you that C plus 2, C plus C1 plus C2 we are adding the things, multiplying the things. Okay, so here we are doing the same thing in this Boolean expression. Okay, tracking the path through the multiplying the individual component, predicting to achieve a Boolean expression. Okay, such as this is your Boolean expression A plus B C, okay, D plus E, F G H I J K I L. This is your Boolean expression. Okay, multiplying the expression to achieve some of the product forms. Okay, so if you are multiplying this, so we are finding some kind of path. Okay. So look at this here. If you are multiplying this A, D, F G H. So this is the one complete one path. So you are taking this as a one thing. Okay, so we don't have any plus symbol over here, any multiplication symbol over here, so we are taking over here. Then we are going to the ij, then k, then I. We have already having the I, so if you are not repeating the thing, okay, then next we are going to the k. This is your one multiplying Boolean expression. Okay, this is one expression, multiplication expression of the your Boolean expression, and this is your first experiment, expression of your Boolean expression. Next we have from A, we are going to the E. Next we are going to FGH, IJ, K, and then L. This is your second Boolean expression. And next we are going with so next is BC, BCD, and FGH, IJ, K, then L. This is your third Boolean expression. And next is BCE, BCE, FGH, IJ, K, L. This is your fourth Boolean expression in the past sensitive. So here what you are doing is you are finding the past sensitive of your Boolean expression. Okay. Each product term denoted a set of inequality that if solved will be the input vector that will be drive the routing along the designing path. So this is your designing path. So it will be rooted in the input vector. Okay. If you can find a solution, then the path is achievable. So if you are finding this kind of solution, your path is achievable. If you cannot finding any solution to any of the set inquiry, the path is unachievable. Okay, this is the difference between achievable and achievable. If you are finding the path of solution, then the path is called the achievable. So you are finding your path of, okay, you're finding your paths over here. So this is the achievable path. If you won't find your achievable path, then it will be called the unachievable path. So the act of finding the set of solution to the path prediction expression is called the path sensitive. Path prediction expression to find out connectivity is called the path sensitive. Okay, so path sensitive is, in simple word, if I say you then. So in the simple word, if I say you that the path prediction is the act of finding the set of input values, so as to find the solution to the path prediction expression. So in this, you are finding the set of input values, guys. So you are finding these values, okay, input value, and you are checking that it is a predictable expressions or not. Okay, so if it is predictable expression, it is called a achievable part. If won't be called the unachievable part. Okay, this is the example of path prediction. In the path sensitive, what you are doing is the bug is occurs. Okay, in this bug will be occur, it called the prediction is fail. So the prediction will be fail. If the bug is occurring, the prediction will be fail. If the bug not occurs, the prediction value is true. So look at this diagram, guys. Example of path prediction. Look at this diagram. So with this, we will create one path table. So we are taking the path in this. So our first path is A, B, C, E, G, H, J, I. This is your first path. Okay. First we are taking the path over here. Then we are going with the path prediction. prediction values. Okay, next we are going the input values. So look at this one. So first path is A, B, C, D. So C, E, G, H, J, I. So you are writing that your path is A, B, C, E, G, H, J, I. So this is your path. Okay, and next path is A, B, okay, C, E, G, I, K, L. Okay, A, B, C, okay, E, G, I, K, L. So this is your another path. A, B, C, E, G, I, K, L. So this one is L, guys. So you are writing over here. Your second path is A, B, C, E, G, then I, K, and next one is L. This is your another path. Next path is, can anyone say me what is the next path will be? Okay, next path will be A, B, D, F, G, I, K, L. This is the another path. Okay. It's visible to you guys? Okay. A, B, D, F, G, I, K, L. This is your another path. It is traveling from one over here to here. Then it is going over there. Okay. This is your one path. Okay, your next path is A, okay, B, D, F, G, H, J, L. This one is your another path. It is traveling over like this. Okay, that is A, so our next path is A, B, D, F, okay, G, H, J, and the L. This is your next part of your contour flow graph. So next we are going with the path value. So here we are giving the path value. Okay, this is for this A, B, this is the title of the diagram, guys. So we are predicting the values here, that is AB, okay, and AB. A is predicted which it is variable by the x is less than 0, and the B means y is greater than 2. That is the prediction. Okay, prediction is x is greater than 0 and y is greater than 2. We are predicting and A and the B. So we are predicting this. So in the first we have the x is equals to 1. That does mean the prediction is true. So here the prediction is true. Are you getting the input value? We are predicting the what we are predicting x is greater than 0. So we value is the x value is x is equals to 1. So the prediction of our thing is we are getting the true. So we are writing the A over here, and in the B we have what we have decided. In the B value should be greater than the 2. So we are having the y is equals to 3. So as B, so these both are the true. So what we are predicting the things in the both the things we are predicting, what we are predicting, we are getting the correct input value. So this one is predicted achievable path. This one is an achievable path of your control flow graph. What we are predicting this, we are getting that thing in this input value. So this is called the path prediction value. So next we have the next graph is AB. This is the next graph. This is our next one. So in this what you are giving the predicting value is A and B. So in the A, what you are giving, the x is equals to 1 and the y is equals to 1. So what we are predicting is x should be greater than 0. So it is x is equals to 1. So it is the true. So over here it is the true, right? In the next section x is equals to 1. So what we are predicting, the y should be greater than 0. So here we are getting the fail. Okay, we are getting the unpredictable, unachievable path over here. So this is the failure of your path prediction. We are getting the input as an unachievable value, unachievable predicting value over in this second graph, second flow. So next we have the A. This one is A, B, D, F, G. Okay, H, J, L. This is your path. So if we are predicting the path A is equals to A and B, and the A value is minus 10, y is equals to 3. So here, can anyone say me that it is predictable or unpredictable? So if we are getting the what value it is true or not? A is true or false? Can anyone say me? Anyone? Yeah, fails. So because we are giving the condition, we are predicting the things A should be greater than 0. So we are getting the x minus 0. So it is a failure of your predicting value, and the y is the 3. So it is the achievable path. So here we are getting the y is the true and the A is false and the y is true. So it is the input value we are getting by the prediction value. So next we have the flow of graph is this one, A, B, D, F, G, L, I, K, L. This is your next flow of graph. So in this we are predicting the a value and the b value, and we are assigning the x is equals to -1 and y is equals to 1. So in this section both are the failures of the predict. So we are getting the unachievable part over predicting path. So this is the path sensitive of your path sensitive. Are you clear with this topic? So in this what you are doing is just here if the bug is occurring, it is called the prediction is failed. Okay, here in this section what we are getting the bug over here, right? So it is a failure of the prediction. Okay, if you don't in this section, in this path you are not facing any kind of bugs, so it is the successful of your prediction value. This is the successful of your prediction value, and this is the unsuccessful of your prediction value. We are testing over in this form. Okay, first in the path sensitive what you are doing means you are selecting the one path, and then you are assuming that you are giving the predicting value of that path, and you are checking that you are getting the achievable path or unachievable path. You are finding in this path sensitization. Okay, are you clear with this topic, guys? So on we are going to test this path sensitive like this. Okay, we are predicting the values. As per the values we are going with the input values. So in the next class, next topic is, are you clear with this?
Yes, ma'am.
So our next topic is path instrumentation. So in this what you are doing means, so what is the meaning of that topic is, in this what we have to do to confirm that the outcome was achievable by the independent path. Okay, so you are checking that your function is providing the correct input or not. You have to check in the various point of view. So which execute the program which will traveling the path. That problem is called the path instrumentation. What its means which is statement running first, and the next statement will check it. Okay, so in this if you are giving the lines of code, so what statement we are getting? Okay, first what statement is running, and the next what line is running. So we are finding in this path instrumentation. Okay, in this we are going with that. Okay, we are checking the flow of statements. Okay, we are checking the flow as a statement from first statement to the next, and next statement till the end of your program. We are checking while running the path instrument, while running your program. Okay. So by doing this, we are getting the output for which statement we are getting the what kind of output. We will get the clarity in with this test, with this path instrumentation. Okay, path instrumentation what we have to do to confirm that the outcome was achievable by the path. Okay, so we are checking that we are checking that the outcome of your path is from where you are getting the outcome of your statement, outcome of your path, we are checking over here. So in this, okay, so if you are writing the lines of code, okay, look at this example, this is diagram. So this is your diagram. Okay, this is your code. Okay, this code is running. So in the path instrumentation, what you are doing is you are finding the outcome. Okay, at what statement, what outcome you are getting. Okay, so you are identifying the things in the path instrumentation. Are you clear with this? what it means which statement run first. Okay, we are checking that, and the next what the next statement will be run, or we will going with that. And with while running we will check it. Okay, by doing this we will get to know output of statement. So we will get to know that output of your statement by seeing this flow of statement. Okay, by seeing this statement, at what statement what output we are getting, we are finding over here. Okay, so next is to confirm that output. If okay, for example, you are running this code and you are getting the output is y is equals to, okay, 2. So you are getting the output. So for what statement what statement we are getting this output, we have to identify this. We will go with the path instrumentation. Okay, by doing this you can identify that at what statement you are finding the error, at what statement you are getting the output like this. So here we have some kind of cases in this diagram. So this is your cases. So in this, at which statement is running, as per that statement you will find out the error. Sorry, you will find out the output. So if your output is y is equals to 2, so which line is running, how you to know that this output is, how it is coming the output of your program. To know that one, you are running the each and every line of your code, then you will get to know that the outcome of your path is achievable. Okay, you get the confirm that this is the outcome of your program. Okay, at this statement we are getting this kind of output. Okay, this kind of output we are confirming that. Okay, flow of growth. So by seeing this diagram you can say that flow of growth. So while running this program, you're getting the output is y. So at which statement the output is, it is getting the output is y is to 2. If you are getting the output is y is, you are getting the output is y is equals to x minus 40. If you are getting this output, so you want to confirm the how and where at which statement you are getting this output to get the thing you are going to with this path instrumentation. So in this you are finding the path over here. So it will check that what flow of thing you are finding this path. Okay, instrumentation. Okay, so in path instrumentation is in simple word that while executing the program we are tracking that program. It's called the path instrumentation. In that we are tracking that program, guys. Okay, in simple word, we are tracking the program at what statement what output you are getting. So in this, if you are getting this output at what statement we are finding we are getting this output, we are getting the clarity of the outcome. Okay, so this is the thing, and this one is the example of your path instrumentation. So in this path instrumentation, so there is so many cases. Okay, in these cases you are getting the output. By this you will get the clarity of your program, that in this statement we are getting the output as a y is equals to 2, and the next year if you are running the mode, then it will be getting the output of, in this statement you are finding the output. Okay, so in this we have the four types of path prediction. Okay, in this first one is interpredictable track the program. So in this what we are doing is we track the program and check the intermediate messages. Okay, check the link that the two links that link with the node. Okay, so what we are doing in this, we are tracking the thing. Okay, and we are tracking the links between the nodes. Okay, we are tracking the thing, and which node we are getting the which node after which that link, what is the next link we are finding in the interpretive track program. Okay. So intermediate path prediction is intermediate track program is one of that execution every statement in order to record the intermediate value of all the calculation the statement they will travel extra. So in this what I know they will record the each and every statement of your execution. Okay, so it will be calculated at which level you are finding the what kind of output. When we run the testing routines under the track, then we have all the information. We need to confirm the outcome and the furthermore to confirm that it will be achieved by the indicated path. So in this what you are saying, in this what I am saying is, so if you are going with any kind of thing, if you are typing your program, so that time you will get you need to have all the information and you need to confirm your output. Okay, so just now I said that with that output you will get that we will find that output with the what statement we are finding that output. We check in this path while doing the tracking with the thing. Okay. So next we have the travel marker and the link marker. It's called a travel marker and the link marker. So look at this diagram, guys. In this, what you are doing is, first of all, go what is the travel marker or a link marker. A simple and effective form of the instrumentation is called the travel marker or link marker, or name ever link by the lowercase letters. Okay. Name will be linked by the lowercase letters. Okay. Instrumentation the line so that the line name is recorded when the line is executed. So what they will do is, put this diagram, guys. They are giving the names to these lines. Okay. Like small letters names I, J, K, L, M, N, O, P, Q, R, S. So they are providing the lines to track the program. Okay, names. Okay, they are giving names to the lines in the small letter. Okay, they are giving names. Okay, each and every line in the small letter. So look at here. This is okay. This is the names of your lines. Okay. Line marker is called, this diagram is a line marker. In this what you are doing is you are providing this is the flow of your program. So that flow what you are giving the lines to the link. So here this node and this node is linked with one line. So you are giving this line as a one name. Okay, marking point. If you are, for example, if you are crossing anything, so if you are marking over that, you are passed from that, so you can identify that this already we are passing from this and this. Okay, so to know that only the flow of thing from one point to another point, we are passed how the program is passing, to know that we are marking to this line. Okay, we are giving small letter marks. Okay, that is in the I, J, K, in the form of alphabet I, J, K, L, M, N, O, P, Q, R. So they are providing this thing. So here, look at here, in the A greater than 7, so we have the condition. Okay, so in this it will traveling from I. Okay, then it will go into the I input. Okay, good. It will traveling from the I. Okay, then it will go into the J. So here we have the decision table S I no. So it may be go in the O or I. So it will go in, for example, for J, then it should be go with K, okay, and then M, okay, then R, okay, then Q. So this is the marker, okay. How we get a output? I is moving to the J and J is moving to the K, then K is moving to the L. So this is the movement of your program, okay. So this is the marking. So you will get the output. By this you will get the output. By this you will find out the things. So 4 characters has a outcomes, okay. By this we get now what kind the output to be, okay. So by this by the flow of this you will get to know that what kind of output should be we are getting, okay, at what marker. So we are going over this, okay. By and this in this section, by this we have some kind of errors in the link marker. So to overcome with this link marker, we have the two link marker. So this is the two link marker. This is the another one of your path instrument, that is, look at here guys. In this diagram we are giving the name of your program, okay, program, that is IJ. We are giving the link to this graph, okay, IJKMA. So this is your you are giving the program. So look at this diagram guys. IKM, okay,
I should take that next, please.
Hello, what ma'am? What you said? Hello.
Ma'am, she is asking to take the attendance, ma'am. We just have 3 minutes left.
Okay, we'll finish this topic, then we will go to that. 2 minutes left. Last topic. Okay, in this book at this diagram. So IKM, okay. So look at this flow of things. So it is going to IKM. So their outcome is coming from the M, okay. We think, but then the M is tracking from M to process B. So look at this. What we are thinking means the outcome is coming from IK, okay. Then M directly we are finding outcome over here. But no, that is not correct. We will think that the outcome is coming from the M. No, but outcome is coming from the process B. Or M, from the M it is going to the process B. Okay. So you are finding the outcome from the process B. Okay. This is your outcome. From your coming from the outcome is process B. So to overcome this problem, we are going with the two-line marker. That is called the each and every line we are giving the two names, okay, 2 characters in the first starting of your line and the end of your line, okay. From this is your line, you are giving the name, marker name here in the starting and the end point of your marker. So look at this diagram guys. So look at this, you are giving only one value, one character. Here you are giving the 2 character I and J. So here by this IJM, okay, then you are giving over here N, okay, N. If it is going to the M, so after going to M, here it is traveling to the process B, okay, and we are getting the output. Then process B it will going to the T mark. So we can identify that your process is, your diagram is, your flow of graph is traveling from IJO NMT. So in the previous example, what you are doing is you are getting the output. What you are thinking is you are getting the output from the M, not you are getting the output from the B, process B. To overcome with this, you are giving the mark a 2-line marker. It is called to overcome with that problem 2-line marker. So if the traveling from, if you are getting the output from M, so it will travel from N and it will go to the N. Okay, so you will get the outcome from N. Okay, then you will get the clarity that then no, your program is coming from the N. If you are coming from the B process D, it will be going with the T. So it will, you will get the input. If it is going from here, it is changing the path from here, so it won't be gave to the end path, right? So you to know that with that you get the clarity of your path. Okay, are you clear with this topic, guys? So now we have finished all your first unit. Only one topic left. In the next class I will cover with this topic also. So to whom I have given the presentations, go with it. Don't give me any kind of excuses, guys. You don't have laptop or anything, network problem, mic problem. I don't want to listen that kind of thing. If you don't have mics, change it.
Ma'am, I will be giving a presentation, but I will not be able to speak. I hope that is okay.
Not able to?
I will, ma'am. I'm not able to speak for long duration, so I will give a presentation on the topic that you've given to me.
So
I will not be speaking.
Wait, take 2 days. Then
thank you, ma'am.
Okay, 16 series. 16 series. Attendance please, guys. 16 series. 17